Hey everybody, in this video we are going to graph the piecewise function you see on your screen right now. Very simple, nothing too crazy. This one is given and it is actually using inequality notation as opposed to using interval notation. So I am going to rewrite it that way as well. So if we need a visual, x is less than 1. Here's 1 right here. X is less than 1, you're not including the 1, and you are to the left of 1. So interval notation, what does that look like? That is going to be 1, oh, no, just kidding. That would be negative infinity until 1, like that, right? Oh, not on the screen. So that would be negative infinity until 1. And then same way, same idea, here's the 1. We are including 1 just on a number line for now, and we're going to the right, greater than 1. It's going to look something like that. So what does that look like in interval notation? That's going to be 1 with a bracket until infinity, like that. And actually I'm going to rewrite that part, I think, in blue, because I think I'll graph one piece of this in red and the other piece in blue or something like that. So yeah. Okay. So really both are totally acceptable, but in my experience, when you're looking at x's between two numbers, or you're looking at x like over here and then again over there, students tend to make fewer mistakes when the question is given in interval notation rather than when it's given in inequality, because inequality, it's not always kind of indicative of the interval over which it's being graphed, because, well, it's not interval notation, right? So let's get going with the first part. We're going to do red for that one, right? Okay. So 1/2 x plus 3 over 2 when x is less than 1. Now, normally people are going to feel very inclined to graph this from the y-intercept, which would be 3 over 2. I don't recommend that, especially for a linear equation. Because it's linear, my slope of 1/2, I can apply it from any point on the line. So to me, the point that makes the most sense is to evaluate that top part at 1. So that's saying, like, figure out 1/2 of 1 plus 3/2. I know this one's easy, but, you know, humor me. 1/2 times 1 is 1/2 plus 3/2, right? And that is 4/2, which is 2. So what does that mean? When x is 2, when x when x equals 1, y equals 2 for the red graph. So I'm going to go over 1 and up 2, and that one is going to be an open circle. Now, the slope is 1/2, so be careful. That means that as we go up and to the right, you're going up 1 over 2, but we're not going up and to the right, we're going down and to the left. Down and left, 2 negatives. Down, left, 2 negatives make a positive. So down 1 over 2, down 1 over 2, and so on. And what that does is it gets us clearly locked in at the correct point where we may or may not have a jump discontinuity. So at 1, when the red graph ends and the blue graph starts, I'm sure of where I am, right? I know that right there is at the point 1, 2. That's the ordered pair, not interval notation. Context clues. Now for the blue graph, I'm going to do the same thing. I'm going to take the 1 and fill it in for x to figure out where along this point of 1, where one graph ends and the other graph starts, where along that, at what height is this function going to start. So that means you'll have -1 plus 3, which is 2. Now that's colored in. So now the blue is colored in, same spot. And then now the slope is -1. So down 1 over 1, down 1 over, because we're going down to the right. Over to the right is positive. Down is negative, and a negative and a positive makes a negative. So right here is the blue graph. The nice thing also about doing it in color is you got to see that while the blue one is the one that's colored in here, because some of you guys were asking about this in class, like, how do I show, you know, that one of them is colored in and the other's not. You can't really show, you know, when you're just graphing with pencil or whatever. It's just, you know it's colored in, and that's good enough. But with color here, you can see That it's the red one that's open and the blue one that is closed. Same point. Now, what else does that mean while we're here? If one graph ends and the other one picks up at that spot without any interruption, nothing is open, right? That means that we are continuous at that time. But that's it for this example. The overall domain is from negative infinity to infinity. My range, however, is negative infinity until 2, right? Or not 2. Yeah, 2. Did I draw that right? Yeah, it doesn't look like it. I swear it's right. Okay, it's over 1 up 2. Negative infinity till 2. Looks like we actually have a local and absolute maximum at that point. And hopefully that was not too bad. So there you go. And if you're happy and you know it, thumbs it. Oh no, it's behind the images again. That's annoying. Up. And if not so much, that's okay. Thumbs it down. Comment, question, concern, request, feedback in the comment section. And there's a playlist with more videos as well as long division videos for anyone practicing finding oblique asymptotes in rational functions. Those are in the description box below. Adios.